Good morning, everyone. So today what we are going to see is about ARM programming. So before starting with the ARM assembly language programming, let me just give a brief overview about how can we do assembly language programming in ARM. So ARM basically follows a load or store architecture. The meaning actually is you cannot perform any arithmetic or logical operations directly in ARM. Then the registers what we are going to use in user mode in ARM is R0 to R14. These are the registers. Every register is 32 bits wide, so you can say 4 bytes in a register at a time. It follows a RISC architecture. That means the instructions are few, but the operands could be more, and most of the instructions will execute in one clock cycle. Whereas 8051 follows a CISC architecture. So the first thing what we are going to see is about load or store architecture in ARM. The meaning actually is in 8051 I could write an instruction like AND A, 40H. What was the meaning? The meaning actually was the value in accumulator A and the address internal RAM address 40H will be added and saved to A. This was the meaning. So directly a memory operation, arithmetic operation in memory was possible in 8051. Whereas in ARM, this is not possible. If you want to perform an arithmetic or logical operation, you have to first load those values into the respective registers, any of the registers, and then after that you have to perform that corresponding operation. So that is the meaning. Now, what are the important flags in ARM? So the important flags are 0, carry, negative and overflow. We will see those in the subsequent lectures, and these flags will be used by the user for programming purposes. And every instruction will have an opcode indicating what operation that needs to be performed along with a set of operands. So first we will see what do you mean by load or store architecture. How can we load values from memory or store values into memory followed by the different instructions in RAM. So let's see the ARM assembly language instructions and programming. So this is an example of a memory address. This corresponds to 32 bits. So how will you say it's 32 bits? Every digit corresponds to 4 bits. So this we have 8 digits. This 1 corresponds to 0001. This 0 corresponds to 0000 and so on and so forth. So we have 8 digits which corresponds to 32 bits. Every digit is 4 bits. The different types of load instructions corresponds to LDR, LDRB, LDRH mainly. And similarly we have STR, STRB and STRH. LDR means load 32 bits from the memory. LDRB means load a byte. LDRH means load a half word. So in ARM, a word corresponds to 32 bits. A half word corresponds to 16 bits. And then a byte corresponds to 8 bits. So LDR R0, if you want to move an immediate value using LDR, this is one way to do. LDR R0, equals 0x, the respective 32-bit value. So when you do this, this value will be loaded to R0. Now if you give LDR R1, bracket R0, what this does is, now from the address pointed by R0, the value will be loaded to R1. So in R0 we had the value 1 followed by 7 zeros. So from that location the value will be loaded to R1. Now LDR B R1, bracket R0 means from the first location. So every memory location corresponds to a byte. So when you do LDR R1, bracket R0, 4 consecutive locations will be, the value from 4 consecutive locations will be taken and then loaded to R1. Now LDR B means only one value will be loaded. I will show an example. LDR H means two consecutive values from the memory will be loaded and saved to R1. So in this case, we had 4 memory locations, one followed by 7 zeros, then one followed by 6 zeros and 1, 2 and 3. Suppose the value, this is AB, this is CD, this is 56, this is 78. Now when you do LDR R1, bracket R0, the value that will be loaded to R1 will be 78, 56, CD, AB. Assuming this follows little endian format. So what do you mean by little endian format? the lower address corresponds to the lowest byte. So this is the lower address, so it corresponds to the lowest byte. And this is higher address, which corresponds to the most significant byte. So we need to read from here to here. If it is big endian format, it will be the other way, where the highest byte, most significant byte corresponds to the lowest address, and the highest significant byte will correspond to the lowest, the lowest significant byte will correspond to the highest address. Now when you do LDRB R1 comma bracket R0, only one byte will be loaded from the location which will be AB. When you do LDRH half word, you will get the value CDAB in R1. So the others will be zeros. The previous byte or nibble will become zeros. Now similarly for STR and STRB and STRH follows the same format. When you do STR, this value will be stored to the location pointed by R0. Bracket always means it corresponds to an address. Now STRB R1 comma bracket R0 means only one byte will be saved to that corresponding memory location pointed by R0. STRH R1 comma bracket R0 means it will be the corresponding half word will be loaded to the address pointed by R0. So just concluding, so loading and storing mainly involves LDR, LDRB and LDRH, and STR, STRB and STRH. And also that you need to remember one more thing. When you are doing ARM programming, this loading and storing, always you should check for memory alignment. So memory alignment means when you do a LDR or STR, the address should be divisible by 4. If it's not divisible by 4, it will give a memory misalignment problem. So because there are consecutive 4 locations is what the registry is going to be loaded with. So the starting address should be divisible by 4. If you are doing LDRH or STRH, the address should be divisible by 2. Otherwise, it will give a memory misalignment problem. Whereas for LDRB and STRB, there are no issues like that. Directly, any value could be loaded from any memory location. I'll give a few examples to see with in the next lecture, and we'll see a corresponding simulator also, where you can simulate this and see what are the respective values that will be loaded from the memory and stored to the memory. Thank you.